In this video we'll look at even and odd functions. So first up, an even function. Graphically we can see that the graph is reflected in the y-axis. So this side of the graph and this side of the graph are mirror images of each other. You'll also notice that when we have a value of negative x and a value for positive x, the y-coordinate, which is f of x, or f of negative x, is in fact at the same value. So we have a reflection in the y-axis, and that's what we have when we have an even function, and we have the y values are the same for negative x and for positive x. So f of negative x equals f of x. Now for our odd functions, you can see it's not reflected in the y-axis, but in fact it has been rotated about the origin. So if I can carefully trace this function here, then we can see that if we were to spin that about the origin, then the curve actually falls back on itself. So it has rotational symmetry about the origin. So for our odd function, we can see that it's been rotated about the origin through 180 degrees. And here we see that the y-coordinates are not exactly the same. If I have negative x, then f of negative x and f of x are not the same as each other. Graphically we can see here that that value of y and that value of y are the same absolute value, but one is positive and one is negative. So down here we have f of negative x is negative f of x, and that's our algebraic way of testing for odd functions. So let's look at some equations and work out whether they're even or odd. So y equals x squared. If we were to consider the graph, it needs to be a reflection in the y-axis to be even, or rotated about the origin through 180 degrees to be odd. So if we were to graph y equals x squared, we can see that that graph there is a reflection in the y-axis. So this part of the curve maps onto this part of the curve. So it appears to be an even function. Let's test the algebraic technique. So does f of negative x equal f of x? So f of x in this case is x squared. F of negative x therefore would be negative x whole squared, which becomes positive x squared, which is in fact the same as f of x. So we have shown that f of negative x is the same as f of x, which is the algebraic means of showing an even function. Now y equals x squared times by sine of x. Let's take a look at that function. So if we were to graph that function, we end up with that shape there, which appears to be rotational symmetry about the origin. Let's trace that function. So here's an approximate trace. So does that rotate about the origin through 180 degrees? Let me spin that around, and you can see it does. So that appears to be an odd function. So let's solve this algebraically. So f of x is x squared times by the sine of x. So f of negative x, we replace x by negative x. So negative x squared becomes positive x squared. And the sine of negative x, we know, is in fact equal to negative sine of positive x. So we simplify that and we'll put the negative out in front, x squared sine x, which is in fact negative the original function. So in this case, f of negative x is equal to negative f of x, and that implies we have an odd function. So we've shown it both graphically and algebraically. So in general, if we have an even function, we know that graphically it's a reflection in the y-axis, and algebraically f of negative x is the same as f of x. So we have two functions here. We've got cosine of x. Let's graph that. So y equals cos of x. We have that graph there. So looks to be a reflection in the y-axis. Let's do the next one, which is y equals e to the power of negative x squared. If we plot that, there's the green curve there. We can see that is reflected in the y-axis. Now the odd functions, once again, we have rotational symmetry. So it is point symmetric about the origin through 180 degrees, and f of negative x equals negative f of x. And I've got two examples here, the first one being y equals sine x, which is this function here. So not symmetrical about the y-axis, but it does have rotational symmetry about the origin. And the second odd function, x cubed minus 3x, once again, not reflected in y, but rotated about the origin through 180 degrees. So that's a quick look at even and odd functions.